In this section, we're going to discuss DHCP, or Dynamic Host Configuration Protocol. Now, in a network, you could manually configure IP addresses on your PCs. And that's not a problem if you have 2 or 3 computers that require IP addresses. But in this example, where we have a subnet of 10.1.1.0/24, you can configure 254 host devices in this subnet. Now, it's a lot more work to go and manually configure 254 PCs. Think of your network at home. Would you manually configure your IP addresses at home? Typically not. Most users are going to allow their broadband or internet router to assign IP addresses dynamically to their PCs, laptops, iPads, iPhones, Android phones, and various other devices that you find at home. It's a lot more work, and it's a lot more time-consuming to manually configure IP addresses on 200 devices. It's a lot easier to configure a DHCP server or configure your home router to dynamically allocate IP addresses to PCs, phones, and other devices. Now, if you had an enterprise network with thousands of PCs and thousands of phones, it makes a lot more sense to configure a server or multiple servers to dynamically allocate IP addresses to devices. This makes even more sense when devices move around. So if a user takes their iPhone from one building to another, you don't want to have to manually reconfigure that device. You want to allow users to roam and move from building to building, and when they connect to a new wireless network, to dynamically and automatically be allocated a new IP address. The last thing you want is users chasing you to simply configure an IP address on their device. Now, the manual configuration of IP addresses varies from operating system to operating system. On an iPhone or iPad, as an example, you can statically configure IP addresses if you want to, but typically it's a lot easier to do that using DHCP. In a moment, I'm going to show you how to configure a router as a DHCP server. So the router acting as the DHCP server will be configured with a static IP address, but another router acting as a DHCP client will be configured to use DHCP to automatically retrieve an IP address from the DHCP server. In this example, I've got a router in GNS3 connected to a cloud. This cloud is looped to my local Ethernet connection. In other words, I'm giving GNS3 the ability to connect to my local Ethernet network. On my local Ethernet network, I have a BT broadband router. This router connects me to the internet. It's also configured as a DHCP server. So my GNS3 router should be allocated an IP address through DHCP. So I'll go onto the fast Ethernet interface and use the command IP address. And we can statically configure an IP address here, or we can use the DHCP option. So we've configured this router to use DHCP, in other words, to send out a DHCP request for an IP address, and I've now shut the interface. So hopefully we should be allocated an IP address, and there you go. An IP address of the following was allocated to the router. This IP address was allocated by a DHCP server. So show IP interface brief. We can see that this IP address was allocated via DHCP to the local router. Show IP route shows us that a default route has been configured. This is my gateway of last resort. So I should be able to ping google.com as an example, assuming that I have DNS configured on the router. We've got to use this command to enable IP domain lookup. And then we should be able to connect to google.com, because through DHCP, we were told that this is the DNS server. So I didn't have to configure any of that. All I configured on the router was this command, telling it to use DHCP, and I told it to use IP domain lookup. But it's as simple as that to configure a router to use DHCP. Once again, you are configuring an IP address on an interface to use DHCP, and in this example I was able to ping google.com or ping other websites such as cisco.com.